In this question, we're asked to draw the Lewis structure of a diatomic molecule, nitrogen. And here, I've put kind of a step-by-step instructions for drawing Lewis structures. And I will try to use these step-by-step instructions for drawing Lewis structures for any of the videos that I make where we're drawing a Lewis structure. And because if you practice and you do this systematically, you can see where you can fix a Lewis structure from maybe an okay one to maybe the best one. So here, let's take a look at how we would use these. So step one, count the valence electrons. So we have two nitrogens. Nitrogen has 5 valence electrons, so we have 2 times 5, which is 10 electrons to place. Normally we want to put the least electronegative atom in the middle. Fluorine is the most electronegative atom. So if we were to think of a periodic table as like a box, and we take out the noble gases because we don't really consider their electronegativities, basically electronegativity increases in this direction. So this would be increasing electronegativity. So fluorine is one of the most electronegative atoms, followed by oxygen, followed by chlorine, and then as they get further away from fluorine, they're less electronegative. Obviously, in this case, this doesn't matter. The least electronegative atom in the middle, first of all, there's only 2 atoms, so there is no central atom. You need at least 3 atoms to have a central atom, and also they're both nitrogen. So we're just going to put nitrogen bonded to nitrogen. All right, if we have more atoms, we might actually have to do this, and we might have to consider the electronegativity, which I did want to review briefly, but here we just want to put nitrogen and nitrogen. Now, fill octets, except for hydrogen, which doesn't like an octet. It just likes a duet, if you will, or just 2 electrons. But nitrogen does like an octet because it's not hydrogen. We have 10 electrons. We have used 2 to make this bond, which means we have 8 left. So let's put them out. 1, 2, 2, 4, 6, 8. I just put them on evenly. You could put the 3rd lone pair over here and only 1 lone pair here, whatever you want to do. But I just wanted to put them on evenly. Note that I have not filled octets. I've used all 10 electrons, 2, 4, 6, 8, 10 electrons, but I have not filled the octet. One thing that I've found over the years that students might do is erase this and try again. And that's not the best strategy. A better strategy is to try and turn what we made into something that fills the octet rule. And if we look at letter A, it says, use multiple bonds if you don't have enough electrons. It would be easier to just put 2 more electrons here and 2 more electrons here. Everything's got its octet. But then it would be N2,4-, which certainly isn't stable. N2 is a very stable molecule. N2,4-, not so much. So we're not going to be able to add a different, more electrons. So we are going to have to use this tip. Use multiple bonds if you don't have enough electrons. So what I want to do is take 1 electron pair off of this atom and put it into a multiple bond. Now you may instantly see that that's not going to work, but if you don't, let's take a look. N, double bond N. And when you see this, what you notice is this nitrogen is still deficient in an octet. It still has only 2, 4, 6 electrons around it. This nitrogen, though, now does have an octet because it has 2, 4, 6, 8 electrons around it. So 1 nitrogen is happy and 1 is not. Let's do that again. Notice that in both cases, I brought the lone pair and made it into a bond. Then I brought the lone pair and made it into a bond. Said another way, I fixed my original Lewis structure, which I wasn't happy with, and I made a new Lewis structure, which I was. Now, have I filled the octets? 2, 4, 6, 8 electrons around this nitrogen. 2, 4, 6, 8 electrons around this nitrogen. I have filled the octets, so I'm good to go. Now it says minimize formal charges. Well, nitrogen likes to have 5 electrons around it, which we use to calculate the number of valence electrons. There are 2 electrons in each of these bonds. However, for each individual bond, we consider that 1 electron belongs to this nitrogen and 1 electron belongs to this nitrogen. So if I want to figure out how many electrons are around this nitrogen, I count the dots as 1, the lone pairs, because this is an individual electron that belongs to this nitrogen, and this is an individual electron that belongs to this nitrogen, and I count the dashes as 1, because this is 2 electrons, but 1 belongs to this and 1 belongs to this. So for just this nitrogen, it has 1, 2, 3, 4, 5 electrons around it. It wants to have 5 valence electrons. It has 5 electrons around it. It is neutral. In this case, for this nitrogen, it's the same. It wants to have 5, and it has 1, 2, 3, 4, 5 electrons around it. Minimal formal charges are formal charges of 0. +1 sometimes is okay, -1 sometimes is okay. Start to get to +2, -2, not so, those aren't very stable at all. So we want to get them as close to 0 as possible. In this case, the formal charges are all 0. So this is the best Lewis structure using this strategy to determine the Lewis structures.